Hello? No?
Hello, sir. Sir. Hello, sir.
Hello?
Hello, sir. Hello, sir.
Can you hear me now?
Hello, Dr. Demetrius,
Yes,
sir.
yes, please.
Yes, sir.
You can hear me now?
Yes, you are. Yes, sir. You are audible, sir.
Okay, good.
Clearly audible, sir.
Okay, just let me share you the. Can you find the PPT? Hello?
PPT, sir. Where? PPT is
PPT.
not coming, sir. PPT is not
Okay,
coming, sir. Please upload it.
okay.
Hmm.
Doc, good evening. This is
Good
Professor PJ.
evening. Yes, yes, Professor, how are you?
I'm fine, sir. How about you?
Very good, very good. But my computer has got problem. Just wait
Oh,
me a few minutes.
okay, sir.
Just a minute. How are you?
I'm good, sir.
Very good. Nice to meet you. Let me try once again to share you.
Otherwise, you can share your PPT to my coordinator, sir. He can present from here.
Okay. Okay.
Yeah, that is also possible.
Okay. Okay.
Yes, yes. Anup, you can take SAR PPT and you can show here.
Okay. Let me give you the PPT, I think.
Yes, yes.
Aye. What happened, please? Let's see. Then
Hello, sir.
okay. Okay.
Now it's coming. Voice
No,
is
sir.
coming.
Voice is coming, sir. Sir, PPT. Voice and video is coming, sir. PPT.
Okay. Here's the PPT, sir.
On the desktop. Yeah. This one.
Now it's okay.
Sir, PPT is not visible, sir.
Not visible still.
Go back.
No. Audio is clear, sir. But PPT is not coming.
Understand. Wait.
Why? No.
Now it will come,
Yeah.
sir.
Coming now.
Coming now?
Just in a moment, maybe it will come.
Yeah.
PPT.
No?
Oh, PPT is not coming, sir.
Okay, just a minute, 1 minute.
Photo is there.
Our video is coming, right?
Video and audio is clear, sir.
Okay.
Yeah, click on maybe share.
Just 1 second. The side will be able to see the content structure screen. Okay. Now?
No, sir. PPT is not coming. Now maybe it will come. Wait, sir. Just it's scrolling. Now it's came, sir.
Okay.
It has came, sir.
Yeah. Fine.
Well,
It's okay? Now it's okay?
sir. Yes, sir. You can start now, sir.
Okay. Thank you so much. I do apologize for my late and busy because of my computer.
No
Sorry
problem, sir. In
for what
virtual
happened.
setting, sometimes
So-
it happens. Every time.
Okay.
It's not at
I
all a
will,
problem. Sir.
Okay, thank you. My presentation of today is on antennas used in 5G technology. So the presentation contents are as follows. The first one is introduction. Then we will see antenna performance and that is key concept, factors affecting antenna efficiency. And then having this information, we will see the role of antenna in 5G. Then we will see types of antenna in 5G. From types of 5G, the microstrip patch antenna and the planar inverted F antenna are the best for 5G technology. So my focus is on microstrip patch antenna and planar inverted F antennas. In fact, we also have dipole antenna, horn antenna, array antenna, and the reflector antennas are there. But my focus will be on the two microstrip patch antenna and the planar inverted F antennas. So let me begin from very simple thing. People can exchange their idea, doubt, or information by sound. They can speak together by sitting together. This only possible if the distance between the two speakers are very nearby. Of course, if the distance is very far, so that we cannot share our idea or information through sounds. So in this case, antenna is must. In fact, the transmission or the conversion of information from one point to another point can be within a wire or wireless. Within wire or waveguide, like fiber optic communication, is very important. But in the case of wireless, we need antenna. So when two people want to communicate without wired communication, we are at a longer distance, we have to convert sound waves into electromagnetic waves. Maybe we can change also electromagnetic wave into sound wave. This is only possible by antennas. Antennas are transducers or devices that convert electrical signal into electromagnetic wave and vice versa. So maybe at the transmitter, we have electromagnetic wave that converts sound wave into electrical wave at the transmission point. In that receiver, we also need the device that convert electromagnetic wave into sound wave or signal. In that case, we need antenna. This is a part. So antenna can be used either transmitting antenna or receiving antenna. The transmitting antenna is one which converts electrical signal into electromagnetic wave and radiates them. And the opposite way is the receiving antenna, which converts electromagnetic wave, electromagnetic from the received beam into electrical signal. So the transmitting and the receiving antenna may work at the same, can exist at the same antenna and can work, or maybe the receiving is another antenna and the transmitting is another antenna. So in two-way communication, the same antenna can be used for both transmission and the reception. But maybe we can have also separate transmission antenna and the received antennas. So what are the concepts? There are parameters that we have to check while designing, fabricating antennas for good performance. The first one is radiation pattern. A radiation pattern is can be represented graphically, which shows the distribution of radiated power from antenna, maybe in many directions or in space. But to have efficient antenna or very efficient antenna, the radiation should be in one direction. So other parameter we have gain. The gain indicates the concentration of power in a particular direction relative to isotropic source. The source may be isotropic. That means the radiation may be in many directions. Comparing it to this isotropic source, the gain may indicate the concentration of power in particular direction. The other point we have to raise in as a key point in the good performance of antenna is polarization. Polarization may be having the electric field in one point as a reference frame. The wave can travel in different directions, which describes the orientation of electric field vector. And the common types are, maybe we have linear polarization, we may have circular polarization, elliptical polarization. In fact, when we come to circular polarization, we may have left circular polarization, we may have right circular polarization. This left and right circular polarization can only exist in some dielectric materials. For example, chiral material, meta materials. In chiral material you can find in nature, but meta material can be manufactured by it is not existing. That means we can produce some material as we like. We call it meta material. So in that meta material and chiral material, you can find left and right-handed polarizations. In that case, we can double our informations by doubling the polarization in this case. So this is one of the parameters that we have to bear in mind. The other is bandwidth. We have to focus on the bandwidth. We need high bandwidth because we are in the era of information. We need high, everybody needs communication. So we need high bandwidth. The angular width of the main loop usually measured between -3 decibel points. That is half point. Maybe we have 5 decibel. If you subtract 3 decibel, we may have 2 decibel. That is half power, which is narrow beam width, corresponding to high dielectric in the focuses. The other point that we have to bear in our mind is the efficiency. The efficiency of an antenna is measured how effectively it converts input power into radiative electromagnetic energy. At the transmission, as I already said, the antenna converts power into radiated electromagnetic energy that can propagate through space. The third point that I have to mention is factors that affect the antenna's efficiency. As you can see from my PPT, there are around 5 factors. The conduction loss is one factor. The conduction loss, the loss due to resistance in the conducting material, maybe copper. Copper, as a nature, it has resistance. Due to that resistance, we may lose some power. In fact, losing power is not a positive or a merit, rather it is a negative side. The other is dielectric loss. The loss caused by material, because I already said material may be dielectric material, due to that some power may be observed. Due to observation, because of the dielectric material, there is a loss. We need to minimize the loss. The third one is impedance mismatch. We may have antenna impedance and the source impedance. 2 impedances, the input impedance and the antenna by itself has an impedance. If the 2 impedances are not mismatched, it is very problem. So we call it is impedance mismatch. If the material has, if the antenna's impedance and the source impedances are not as such mismatch, it is a positive sign or a merit. The other is radiation loss. Due to radiation in the space, the power that we feed to the antenna may be lost due to imperfection of the mechanism during the material manufacturing. During manufacturing, maybe due to imperfection, there is a radiation loss in the antennas. There may be practical efficiency values we have. If it is high efficiency, we have to have at least above 90%. And for low efficiency antenna, it may occur below 50%. So the fourth point is about the role of antenna in 5G. The role of antenna in 5G it is a critical for transmitting and receiving high frequency signals, enabling faster and more reliable communication. So the key features are: one, we have to have high frequency operation. In high frequency operation, it is based on millimeter wave. Millimeter wave is range from 24 to 100 gigahertz. In this frequency range, we can get a high frequency operation. So in 5G, we have to use millimeter wave frequency range. And also, we have to have high gain and the beam forming capabilities. To have 5G technology, the antenna must have high gain in beam forming capabilities. And also, it must support MIMO, massive MIMO. I think Dr. Avatar present on this, on massive MIMO, multi-input, multi-output technology. This technology also supports 5G in 5G antennas. So the application of antenna efficiency is very important in this case. The 5G technology, highly efficient antennas are required to reduce power loss in beamforming array in the high frequency operations. So the macro strip patch antenna is also has high efficiency and reduce power losses, and so we can use in 5G technology. We will see that one. Then the other important point is IoT, Internet of Things. Devices that efficient antenna minimize power consumption and prolonging battery life. The battery life is also long, and power consumption is very less. Such device is also very important in 5G, in the role of antenna in 5G. So the other is they can operate, they can work in satellite communication, which is efficiency is critical in ensuring long-range signal transmission. These are the short role of antennas in 5G. In 5G, we will cover these all important factors. Saying this, as the fifth point, I will come to address antennas in 5G. Yeah, we have different kinds of antennas that works in 5G, but most of them, the macro strip patch antenna and the planar inverted F antennas are the most important one. When I'm saying this, dipole antenna, horn antenna, array antenna, and the reflector antennas are also used currently in a 4G. Also, they can work for 5G, but for 5G and beyond, where the most important one is macro strip patch antenna and the planar inverted F antennas. So I will give more attention for the first two, and then I will leave the list the remain for anyone interested for reading. Okay, so let us see one by one. Microstrip patch antenna, as you see from the PPT or slide, from slide, you have a picture. If it can clearly seen to you, the blue one is the patch. This patch is used to radiate electromagnetic waves. The other part of this structure or microstrip patch antenna used for reflecting surface. You can see the height, the width, that is T for the patch, and the width W for the patch, and the length also. We can simply not give numbers. The length, the width, and the height of this patch and the substrate are affected by many factors, and the need is to a mathematical manipulation. So the down one is the substrate, which is grounded plane. This dielectric substrate has dielectric constant. The dielectric constant can be found inside this material, the material from which it is made of. And it is most basic for microstrip patch antenna consists of radiating patch. It used for radiating on one side of the dielectric substrate, which has grounded plane on the other side. For a good antenna performance, a thick dielectric substrate having a low dielectric constant is desirable, since this provides efficiency, larger bandwidth, and the better radiation. To evaluate the radiation, to evaluate the performance of our antenna, bandwidth is one factor, radiation is another factor, and again the battery life is another important thing. So the dielectric material of the patch must be thick. If the dielectric is thick, in fact, it needs more power. The more power, the more the cost. But if it is thick, it has low dielectric constant. If it has the low dielectric constant is the thing, the desired requirements, because it gives better efficiency, large bandwidth, and the better radiation. It gives the radiation in one direction. We will have a big bandwidth, and also in that case it is more efficient. So based on the shape, the patches usually feed along the center line to the symmetry, and that those minimizes the excitation of undesirable modes. So macro strips can be many based on their shapes. Maybe the next figure can be simply seen. Patch shapes are, you have square, rectangular, dipole, circular, elliptical, triangular, disc sector, circular ring, and the ring sector are the few. This is the patch part. The patch part can have these shapes. Based on the shape, we can have, it may have some merit and some disadvantages. Also, you can have penta gun shapes due to different shape of the patch, the performance, the quality of the antenna is also vary. Also, you can have single slot radiator. You have also, we call this a slot radiator. And also undersea, you have macro strip traveling wave antenna. It look like traveling wave, so that its name come from traveling wave antenna. The first one, it look like comb, and it is giving us comb. And the next is Minderline type, and the other is rectangular and Franklin type antennas. So from different shapes, you can get different quality and different performances. So from the substrate part, for example, depending of the material, honeycomb one that we have seen, the dielectric constant is 1.07. Duroid, dielectric constant is 2.32. Quartz, dielectric constant is 3.8. Alumina, it is dielectric constant is 10. So a thicker substrate will increase the radiation pattern, means we need the small number of dielectric constant. If we have more dielectric constant, that means high signal loss. More dielectric means more signal loss. Less dielectric means less signal loss. So the dielectric constant has also the effect is on the performance of our antenna. So this dielectric constant is come from the material. Is that a metamaterial from which it is made of? So the engineer or the producer or the manufacturer must bear in his mind during manufacture about the dielectric constant. At this point, we will see, we compare various types of antennas, and we will compare each of them. At the first column, we have profile, fabrication, polarization, dual frequency operation, shape, suppress radiation. Within that, horizontally, we have macro strip patch antenna, macro strip slot antenna, and the macro strip dipole antenna. Let we compare one by one. Generally, on the profile, they all similar. Thin, because of it thin, it is a small side, it is very easy to carry out. And also fabrication is very easy in the case of macro strip patch antenna, but easy in the other two antenna case. In polarization, in the case of macro strip patch antenna, it has both linear and circular polarization. Of course, in macro strip slot also we have both linear and circular, but in the printed dipole antenna we only have a linear polarization. So in this case, up to now, this point, macro strip patch antenna is important, better than others, because it is very easy for fabrication and it has both linear and circular polarization. By this case, microstrip patch antenna is better. And also dual frequency operation for all, it is possible. Shape, they have different shapes. So easily comparison within this very few parameters, microstrip patch antenna is better than microstrip slot antenna and Pennington dipole antenna. Let me see the advantage. We will see the advantage and the disadvantages also. In patch antenna, yeah, low fabrication cost. We already said in the microstrip patch antenna, it is the fabrication is very easy, it says, yeah. So low fabrication cost, hence can be manufactured in large quantities. This is its merit or its advantage. The other advantage is easily integrated within microwave integrated circuit, and also very capable of dual and triple frequency operations. And it can support both linear and circular polarization. Even it can support left circular polarization, right circular polarization, and also it can be a sort of some other sort of polarizations, like elliptical polarization. The other thing, the other advantage is low cost. We say it has low cost, and also it is less size. So we can carry by hand. It is less size and low mass. That means easy to carry from one place to another, and it cannot consume more power. Mechanically, it is very robust when mounted on rigid surfaces and has high performance. And lightweight, as we said, low mass. Lightweighted in the low volume, and that is a small size. These are the few advantages. In fact, one can list out more advantages for this microstrip patch antenna. The disadvantages are, when we read this, all are disadvantages, but it is narrow bandwidth is also can be account as disadvantage in the low gain. It is gain is about 6 decibel. This is also the disadvantage. Large homotic loss, that is a material. The loss due to material is also high because of it is substrate, maybe not thick. Excitation of surface waves is also occur. Most microstrip antennas radiate into half space. Maybe we need that the radiation is in the direction of the propagation, but sometime in microstrip antenna, radiation may be in space. This is because of some factors. It also have relatively low efficiency due to dielectric and the conductor losses. We have conductor loss, like a conductor loss means if the antenna is from copper, due to copper, there is a loss due to its material medium. And also, if it has dielectric is very high, due to that, the efficiency is low. The other is relatively high level of cross polarization that may be interference in the suppressed feed radiation, surface wave strips, inherently low impedance bandwidth. if the bandwidth of the source and the bandwidth, if the impedance of the source and the impedance of the antenna are not mismatched, this is also one of the problem. And also low efficiency. This is comparative thing, because when we say low efficiency, we mean that it is not as such. Okay, how to overcome these problems? The problem, the disadvantage can be overcome by using the look. The low power and the low gain can be overcome by array configuration. Array configuration means you may have single antenna by using different antennas. You can superpose different antennas. You may have 1 to 5 antennas. If you configure 1 to 5, maybe 3 antennas together or 5 antennas together, you can make array antenna. The array antenna configuration can overcome the power, the loss of power, and the low gain also overcome it. So the manufacturer or the designer or the engineer can bear in his mind to reduce the low power and the low gain by using array configuration. The other is surface with associated limitations such as poor efficiency, increased mutual coupling, and the reduced gain radiation pattern and can overcome. And the third one is the bandwidth can be increased up to 60%. The bandwidth can be increased, 60% is above half, can be increased 60% by using some special techniques. This special techniques is simply array configurations. The array configuration means you can configure number of antennas by making a single antenna. If that, it can increase the bandwidth by 60%. Then it is application. The application of macro strip patch antenna. The macro strip patch antennas can be used in mobile satellite communication system, in 5G and beyond also. That is why I give attention here. So direct broadcast television is also can be applied by patch macro antenna. And also in wireless LAN, we can use it. Wireless LAN is also can be operated by microstrip patch antenna. And also you can use feed element in the coaxial system. Coaxial simply mean copper cable. And you can use for GPS system, missiles and telemetry, ultra high frequencies, that means UHF patch antenna for space communication. These are the application we have seen in this part, the introduction part. We have seen the shape. We have seen it factors that affect its performance. We have seen its advantage. We have seen its disadvantage. We compare advantage and the disadvantage. We have seen its application. So this macro strip patch antenna are very important in current technology. The current technology is 5G and beyond. So we use macro strip patch antenna for this, and also you can calculate the patch length by this. This is maybe if we are interested, we can have the PPT. And also one thing I have to mention here is the macro strip patch antenna have a very high antenna quality factor. If the Q factor, we can calculate the Q factor, that is the quality factor, represents the loss associated within the antenna and the loss associated with the antenna. You can find the value for quality factor Q. The larger the Q leads, the narrow bandwidth, and the vice versa. And also, it is if the value that we calculated in quality factor is large, it means it is low efficiency. So Q can be reduced by increasing the thickness of dielectric. If that number is high, we can increase the thickness of the dielectric substance or substrate. But as the thickness increase, an increasing fraction of the total power delivered, yeah, maybe it can consume more power. But we have to see the advantages, disadvantages when we are comparing these things. So the second antenna that we will use in 5G network, the 5G technology, is planar inverted F antenna. As usual, let we see the introduction. In the inverted F antenna, typically consists of rectangular planar element located above the ground plane, a short circular plane or pin in the feeding or in the source for mechanism for a planar element. One thing we have to see, this planar inverted F antenna is named due to its shape. It is the inverted shape planar. Its shape appears like an inverted F, and hence named as a planar inverted F antenna. So the PIFA, that is planar inverted F antenna, is also referred to as a short circular microstrip antenna. You know, this planar inverted F antenna is basically derived from macrostrip patch antenna. It is improved one. This is an improved one. So this planar inverted F antenna is derived from what we have seen, that is macrostrip patch antenna. So PIFA is also referred to as a short-circuited macrostrip antenna due to the fact that its structure is resembled to short circuit. It can be considered as a kind of linear inverted F antenna within the wire radiator element is replaced by a plane. We will see the shape that is. So why planed inverted F antenna? Why we use this PIFA? It has an omnidirectional. Omnidirectional simply mean one direction. It is not many direction. We also need that one. The radiation from antenna must be in the direction of the propagation. That enhances the efficiency of our antenna. So in PFA, the radiation are omnidirectional. Omnidirectional direction pattern, and the provide is high gain in vertical in the horizontal direction. This is a very important thing. It has a simple structure and can be easily hidden in the handsets. It has self-resonating structure. The resonance frequency, it has a self-resonance structure. That means good for high frequency. An antenna radiator is just mounted above the ground layer. There is PCB plate between the antenna radiation and the plate and the human brain like. Let me see the structure. If you see the yellow one, if it is seen on PPT, from this you have what? The input. The power is given in this inverted FA. This is a tapper. So in this case, if you see this, you also have the width in the length. In fact, you can feed the power in this part. This is the design structure for PFA. And also, simply to remind someone, you can have a basic equations that are used for calculation the PIFA. For example, the length of the patch can be given if the length of the patch plus the width of the patch can be given 1/4 of the wavelength. The wavelength is the wavelength of the interest, the wavelength of the carrying frequency. So this is one can see. The objective of this antenna is in wireless communication low profile antenna that supports multi-band wideband operation is required. In order to meet those requirements, PIFA is being used, particularly for wireless communication like massive MIMO. We can use this antenna. These antennas are compact and support multi-band and wide-banded operations. Therefore, such antenna are suitable for devices where space is a major issue. So PIF has low backward radiation and hence minimizes electromagnetic wave absorption, or you can say the electromagnetic observation is less. That is one of the merit that we have for good antenna. The other is this antenna is many wide application in today's electromagnetic electronics world in current in our era, because PIFA is derived from patch, microstrip patch antenna. It has many advantages over that, so it can be used in our current technology. That is 5G is also one of. Okay. The other is for those who want to work research, just only to give the hint, there are many types of antennas that need to investigate. That is many people are working on. And we have a software. This software is HFSS. We call it is a software used to design, simulate, the high frequency antenna. Its abbreviation is high frequency simulator structure. So HFSS you can find freely to simulate high performance or wave electromagnetic wave field simulators. So one can use these simulators for research purpose case. So these are some of the part or some of the antennas within different shapes, within different function. One can see, and due to time I have to run. You can see as macro strip patch antenna, in plane inverted F inverted antenna, we also have different shapes. Based on the shape, we have different functions, different performances. In this case, what are the advantages? As usual, let we see the advantage. It can be hiding into the housing of the mobile, while comparable to whip or rod helix antennas. It also reduces the background radiation towards the user. We have said also the pattern of the radiation is in the direction of the propagation. It minimizes specific observation. Observation is a loss. Loss is a factor that affects the performance of the antenna. In that case, minimizing the specific observation is also the desired requirements. The other advantage of PIFA antenna is it exhibits moderate to high gain in both vertical and horizontal status of presentation or polarization. The other important thing, it is low profile, and compact in size. That means the volume is small, the size is small, it is compact in size, and very easy for fabrication. The fabrication is very easy. And it is structure is also simple structure, easy fabrication, compact in size, low profile are the advantages that we can get from this kind of antenna. So as a starting point, I said this antenna is derived from macro strip patch antenna, so it has this kind of advantages. As usual, we have advantages and disadvantages. There are so many properties that is good advantages, but only one disadvantage is there that makes it complicated to use. And the disadvantage is the narrow banded. So during manufacture or during design, the engineer should see the substrate, the dielectric material, so that the dielectric constant must be low and the substrate or the patch must be thickness, and also less dielectric constant, so that we can solve these disadvantages. The narrow band characteristic of PIFA is the one that limits the limitation for it is concern commercial application for wireless mobile. So we can improve its bandwidth by increasing the size of the feed plate or the width, but after that, antenna become very sensitive for changes. Yeah, sensitivity also is undesirable. Undesirable. Okay. Within that, we, as usual, let we see that it is application. PIFA antenna for handled devices you can carry from place to place easily because it is very compacted and weightless. This antenna is widely get used for MIMO application. As we said, multi-input, multi-output antenna. So this antenna is also used for this. PIFA antenna has used also in medical application, and the inverted antenna also used in vehicle elements, in vehicle communication also. So it has many application, many advantages, and a few disadvantages. So the two antennas, particularly the planar inverted in and that the patch antenna are the very important one, and their application is also look like, the same. In fact, one is the planet inverted F antenna is derived from that macro strip patch antenna, and almost many of their elements are the same. We also have other antennas. For example, is dipole antenna. The dipole antenna simply for rough. I don't go to deeply. You have one antenna, charges in different point, which are equidistant from the center of the antenna. So one is the negative and the other is from positive. That is why it gets the dipole moment. And from that, you can change the shape, and the radio frequency voltage source is given at the middle. That is the source of the antenna, and then the voltage and the current is applying through the two conductive elements because they are not connected directly, and they generate an electromagnetic in the radio signal, and this signal is radiated outside of the antenna. So it performs the antennas. At the center of this antenna, the voltage is minimum, and if the voltage is minimum, then the current is maximum. Whereas if the voltage is maximum, in the reverse way, the current is minimum for dipole antenna. So the dipole antenna is a type of radio frequency antenna that includes two conductive elements like wires, rods where the metal wire length is half of the highest wavelength approximately. That is used in free space operation of the frequency. So the radiating element length can be determined by this formula, and you can see it is halved now. Before it is lambda over 2. Now by having lambda over 4 in both sides, they are equal distance, and the power is given in this direction. So you can see the dipole antenna we have this antenna and the next antenna also. This is a transmitting antenna and this is a receiving antenna. Both antenna is in different distance, maybe at a different device also. The voltage as a preferred frequency is provided to the antenna, so the voltage across the power, it means the voltage when I'm talking, the voltage is the power across the elements of this antenna flow to the current. Throughout them will create a magnetic as well as electric waves, so that the transmit section, the dipole antenna generates radio waves. Radio wave. Who said the corner ega Canada digdama? Devi kaka. Okay, so let me actually go through, because this is not the main part of one can read also. We can see also the advantages, simplicity in main advantage of the antenna. We can say many things regarding its an advantage. We can have many disadvantages. For example, the wavelength is long for very less frequency. To make an antenna is one, and also for below 27 megahertz frequency, the antenna efficiency will start reducing when the length of the antenna decreases. This is also very disadvantage. In the application, if you want to see the application, the antenna in this case, the dipole antenna is applicable for radio telecommunication, because this is not for this 5G. The same antenna is used in two ways communication for both transmission and reception. Halfway type antenna can be used for TV radio services. Okay, we have also horn antenna, which is work from 300 megahertz to 30 gigahertz, high frequency, that from the shape, due to the shape. هذا تنشي قوي له. هيدو. Sorry, they are interrupted because of time. Let me come to the last point, that is summary. Yeah, this must, let me go through this. The array antenna, I have said before, if having different antennas, if we configure to make one antenna, it is very, you can see this, the array, you can say vertical and horizontally. An antenna array definition is a group of antenna. I have said it before, a group of antennas that are arranged to form single antenna. If you see the picture, there is different antennas, many different antennas, N by M. If you arrange this many antennas in the form a single antenna, we call it this array antenna, to generate radiation pattern, but not generated by individual antennas. So the set of antenna will work together to transmit and receive radio signals. Okay. For the antenna array, proper spacing in the phase must be given. The space between one antenna to another antenna in that phase must be, where the designer or the engineer should keep in his mind the phase match. The phase match is one of the factors. So array antenna is also the important antenna that our current technology can be used. And so you see the distance between the arrays, between the antennas. These are many 5 antennas, very within a different distance. So an array antenna array is designed by arranging several antennas to make a single system to provide high directive antenna. The antenna within array must be spaced properly in the proper phase so that the independent contribution of every antenna within the arrangement in the same direction gets added up or superposed, whereas it gets a cancelled out in the rest all other direction. Yeah, we have to. So generally, an array antenna, the current within different antenna elements are in phase if it achieves highest value on the following throughout similar direction of the same time. Thus, once the antenna elements are fed or given the power that means within the proper phase from every element of the array, the spherical waves are superposed because of interference and they generate a radio wave. Hence, here is the system that works. The interference, sometimes maybe it can create interference, can be either constructive or destructive. If it is constructive, it is good. That is a superposition. If it is destructive, sometimes maybe it cancel each other. So let me pass to the advantage. The advantage and the disadvantages of this array antenna, the strength of signal increases very strongly. High directivity it can be achieved. The directivity can be achieved. Minor lobe size is reduced drastically or very highly. Obtaining high signal to noise ratio is also possible. Large gain can be obtained. We can have large gain. And the amount of power wastage is also reduced. There is no power dissipated or there is no power consumption, more consumption. Achieving a better result is possible. The antenna array design is simple, support better performance of antenna. Many can be said. The signal to noise ratio is also very less. The disadvantage, also, antenna array are expensive because of it has many antennas merged to make one single antenna, and that its structure is complex. The antennas are very expensive. This antennas is very expensive. Resistivity loss will be increased. Yeah, there is many loss. And also it requires high maintenance. Usually during maintenance, you may incur cost. The cost for maintenance is high. Mounting is difficult or installation is very difficult. It occupies huge external space is some disadvantages. Where we can apply this, an antenna array is very helpful in increasing the overall gain and increasing the signal to noise ratio or signal to interference plus noise ratio. You can say simply signal to noise ratio. The noises come from interference and cancelling out the interference if it is out of the face, not to superpose. Cancelling out interference, providing directivity of reception, moving the array within particular direction. That is the important thing. The pattern or the radiation pattern is in the direction of the propagation, it means measuring arrival of the incoming signal direction, etc. are very important application. The antenna array is used in wireless, military, radar, satellite communication also used. Those arrays utilized within observation of the astronomical data. Those are mostly applicable in long distance communication and also mobile communication. If it is used in mobile communication, maybe this is also applicable in 5G. Those are used whenever a high signal strength is required for long distance transmission and reception. The last one is maybe reflector antennas. The name is come from its shape. If you see, the antenna shape is look like convex lens. It look like convex lens. The ray and the light power that is comes, the signals that come from the focal. If you see from the focal, goes to the lens. After reflection, it is keeps parallel. So parallel radiation pattern. It says the reflector antenna definition antenna that is designed for reflecting the incident electromagnetic signal orienting from separate source. This antenna is mainly designed to function high microwave frequencies. You see, from different sources, the source is here one, from the focal. It reach the surface, the source means the power or the incident light electromagnetic signal. The incident, this is the incident. The incident electromagnetic signal, or you can say signal, after reaching the surface of the antenna, it reflects back. But the reflection never meet. They keep parallel. And this is very important for the function for high microwave frequencies. So it is most popular within spacecraft antenna system due to lightweight, very light, so that we can use for spacecraft in the simple structure. This antenna is made with various reflectors whose surface is hyperbolic, that is convex, parabolic or spheroid, or elliptical, so that the parabolic is the most frequently used antenna like this. So how does this work? It is work principle is electromagnetic wave of this frequency performs light wave, so that the light wave gets reflected back once it strikes the surface of the antenna. However, this antenna is combination of reflecting surface and feed elements within, which means reflecting surface within an element of antenna. You can see it. This is the reflecting surface of the antenna. This is the feeding or the source. So the antenna used to provide excitation is called the active element, whereas the one that again radiates the emitted energy through, or power through the active element is known as the passive and active elements are there. So the reflection pattern, this is the plane, that is convex, only the difference is the material. So as we see, from the feed point or the source, it reaches the plane mirror, the plane like a plane mirror. Then it reflects back. And the other thing is similar to that of the convexing antenna. This also corner reflectors, only the shape is changed. Yeah, you can see cylindrical and spherical shapes. So this is also a good antenna, rod reflector antenna. You have many antennas within different distance, like we call it is Yagi Unda antenna, a kind of antenna that has a rod shape reflector known as rod reflector antenna. And the rod type reflector is mainly used in Yagi Uda antenna. This reflector arranged in a particular distance in back of the driving element within the antenna. So it is advantages are those antennas are very stable and they have outstanding radiation performances, and a parabolic type in antenna, the shape, and the parabolic reflector decreases the minor lobes, and also the amount of wastage power, the wastage of power, that is the power consumed, is fairly low as compared to the other antennas. These advantages are there, and also the reflecting antenna needs to be balanced to keep away from the out extraction of the feed point. From the feed point, the distance must be kept. For example, you can see this. No, you can see this is the source. This is antenna. We have to have the feed point is as the focal point, as the focal, not everywhere. What I did. Sorry. Let me finalize the cause of time. Yeah, as a summary, smartphones like 5G and beyond, they are compact, needs compact antennas like PIFA that we discussed, the macro strip antenna, macro strip patch antenna, and the plane inverted F antenna. The two are the very important antennas that support smartphones. They enhance mobility and the connectivity. The base station is high gain array in the reflector antennas, in the beamforming in the high coverage antennas. 5G requires diverse antenna designs for high frequency and high bandwidth operations. So macro strip, planar inverted F antenna, array antennas dominate the application over the other antennas. Advantages of antenna technologies are a key to use in 5G. Feature design focus on smart, efficient, and adaptive antennas. Within this, I can say many thanks for you for having time and sharing your very expensive time for me for my presentation. Thank you so much.
Dear participant, any queries? Sir, some queries are there in chat box. Shall I read now?
Okay.
Sir? Some queries are there, sir, in WhatsApp. Sorry, in chat box.
Hello.
Any participant? You have any doubts? Sir, Timothy, sir.
Yes.
Janagiraman sir is also there. You want to talk to him?
What?
Janagiramalu. Sir, principal
Yeah.
sir. Sir,
Yes.
మాట్లాడండి.
Hello.
Yes, yes, sir.
Yeah. I'm hearing you.
Yes, sir. It
Yes,
was
yes.
nice presentation, sir, and thankful to you for your patience and making such a huge presentation.
Thank you so much. Thank you, Professor PJ, for
Yes, sir.
we work together again.
Thank you, sir.
Yeah, the network is not as good like your country. You better
No
know.
problem, sir.
Yeah.
Yeah, I know, sir.
I go quickly. My PPT is too large. I want to cover all.
Okay, sir.
In fact, yes.
Thank you so much, sir. Thank you so much, sir. Your expertise helps us understand about fundamentals of antenna parameters and characteristics, different types of antennas such as dipole antenna, monopole antenna, microstrip antenna, and radiation pattern. Madam, please.
Madam, can you please share recording of?
Yes, I put your in your email. I shared to you through your email. Please look your email I gave you.
Okay, sir, it has come. Vani ma'am. Hello, Vani ma'am.
Hello.
Okay, sir. I would like to say thank you, respected Dr. Demisi Jobir, sir. Your presentation on antenna technology used in FG was not only informative but also very engaging. We have gained a valuable insight that will be surely contribute to our professional growth and understanding of the subject. On the behalf of ECE Department, Samskruti College, I would like to extend our heartfelt thanks to our speaker, Dr. Demisi Jobir, sir, for sharing knowledge and experience with us. And sir, we also appreciate the time and effort you took to prepare for today's session, despite of some virtual setting challenges through computers and all. Sir, we really appreciate your effort. Thank you, sir. Thank you so very much, sir, for being a
Thank you
part
so
of
much.
this.
Thank you so much, sir. Thank you. Thank you having you here and having sharing our ideas. Thank you so much for your appreciation too.
Okay, sir. Thank you, sir.
Thank you.
Okay, for the participants, this was a really good session by our Dr. Demisi Jobir, sir. Next session 2 will be held by Dr. K. Jayanti. Just we'll take a small break, maybe of a few minutes, and then after we will come back with Dr. K. Jayanti ma'am, who will be demonstrating her presentation. That will be the second session of today, 5th day of our faculty development program. Okay, ma'am.
Session 9.
Yes, ma'am. Tell me.
Hello.
Oh, ma'am. Just in a few while we will start the meeting. Or if you are ready, we can start it now. Also, just in 2 minutes we will start, ma'am. Okay.
Yeah.
हाँ, ma'am.
I'll just wait for 2 minutes, sir.
Thank you.